Hello, my name is Megan Nelson, and today I'll be sharing with you my presentation from the 2023 American Society of Animal Science Midwest meeting titled Effects of Different Protein Sources in Low Phosphorus Diets on the Basal Endogenous Loss of Phosphorus. To start with a brief introduction, digestibility is defined as the disappearance of a nutrient from the gastrointestinal tract. One way we measure digestibility of phosphorus is by measuring the intake of phosphorus provided by the diet and the amount of phosphorus excreted in the feces. By taking the difference of those values, we can calculate the apparent total tract digestibility of phosphorus. However, apparent total tract digestibility does not account for endogenous phosphorus that is excreted in the feces, which may result in the underestimation of apparent total tract digestibility values. Endogenous phosphorus can originate from secretions of the pancreas, gallbladder, stomach, and salivary glands, as well as sloughed-off enterocytes, intestinal enzymes, and mucin. Endogenous phosphorus that is not reabsorbed in the small intestine will be excreted in the feces. One way we can account for endogenous losses is to feed the pigs a phosphorus-free diet and measure the amount of phosphorus excreted in the feces. And since we are not providing any phosphorus in the diet, we can assume that any phosphorus excreted in the feces is of endogenous origin. This will allow us to determine the basal endogenous loss of phosphorus, which is the inevitable loss of phosphorus from the body that is related to dry matter intake. The NRC has determined that the average value for basal endogenous loss of phosphorus in growing pigs is 190 milligrams per kilogram of dry matter intake. We can then correct the apparent total tract digestibility values for basal endogenous loss of phosphorus to give us values for standardized total tract digestibility. Because the values for standardized total tract digestibility are not affected by the level of phosphorus in the diet, these values are considered to be additive in mixed diets. This provides a better prediction of the concentration of digestible phosphorus present in a feed ingredient and allows for more accurate diet formulation. Gelatin is often used when formulating diets to determine the basal endogenous loss of phosphorus because it contains no phosphorus and it is a good source of protein for the pigs. However, gelatin can be dusty and sticky and can lead to the abnormal status of the animal both nutritionally because of reduced palatability and physiologically because no phosphorus is being provided in the diet. Some alternatives to gelatin include spray-dried plasma, casein, and potato protein concentrate. Spray-dried plasma is sometimes used to determine the basal endogenous loss of phosphorus because it is assumed that the phosphorus contributed by spray-dried plasma is 100% absorbed. Potato protein concentrate has also been used in at least one study to determine the basal endogenous loss of phosphorus because, similar to gelatin, it has a very low concentration of phosphorus. Another possible alternative to gelatin would be casein, because like spray-dried plasma, the phosphorus in casein is close to 100% digestible, and this ingredient is also high in protein. However, to our knowledge, it has never been confirmed if the basal endogenous loss of phosphorus is the same if estimated from diets containing gelatin, spray-dried plasma, casein, or potato protein concentrate. Therefore, the objective of this experiment was to test the hypothesis that the basal endogenous loss of phosphorus from pigs fed a diet containing spray-dried plasma, casein, or potato protein concentrate is not different from that of pigs fed a diet containing gelatin. For this experiment, we utilized 40 pigs with an average body weight of 19.34 kilograms. These pigs were individually housed in metabolism crates and were randomly allotted to 4 experimental diets for a total of 10 replicate pigs per diet. Experimental diets were based on cornstarch and sucrose. Diet 1 contained 20% gelatin. Diet 2 contained 20% spray-dried plasma. Diet 3 contained 18.5% casein. And Diet 4 contained 20% potato protein concentrate. The only phosphorus provided in the experimental diets was the phosphorus that came from the protein sources. And therefore, the gelatin diet contained 0.02% phosphorus. The spray-dried plasma diet contains 0.31% phosphorus. The casein diet contains 0.14% phosphorus. And the potato protein concentrate diet contains 0.03% phosphorus. Pigs were fed at 2.5 times their maintenance energy requirement, and daily feed allotments were divided into 2 equal meals that were fed in the morning and in the afternoon. Experimental diets were fed for 12 days, with the first 5 days considered adaptation to the diet, followed by 4 days of feces collection using the marker-to-marker procedure. Feces collection began when the first marker fed in the morning of day 6 appeared in the feces, and ceased when the second marker fed in the morning of day 10 appeared in the feces. Collected feces were analyzed for phosphorus. For this experiment, we utilized the mixed procedure in ASAS, and the model included diet as fixed effect, and block as random effect. The experimental unit for this analysis was pig. Moving on to the results, pigs fed the gelatin diet had the lowest feed intake compared with pigs fed other diets, and this is likely due to the reduced palatability of the gelatin diet. No differences were observed in the apparent total tract digestibility of dry matter among pigs fed the gelatin, spray-dried plasma, and casein diets. However, pigs fed the potato protein concentrate diet had reduced apparent total tract digestibility of dry matter compared with the other diets. This could be due to the fiber present in the potato protein concentrate compared with the other protein sources that do not contain any fiber. Phosphorus intake was different among all diets, which is what we expected due to the differences in the amount of phosphorus present in the diets. The gelatin diet had the least amount of phosphorus, and therefore the pigs fed the gelatin diet had the lowest phosphorus intake, whereas the blood plasma diet had the most phosphorus, and therefore these pigs had the greatest phosphorus intake. Pigs fed the gelatin diet had the lowest feces excretion, and this is likely due to the reduced feed intake observed in these pigs. However, although the feed intake was not different amongst pigs fed the spray-dried plasma, casein, and potato protein concentrate diets, pigs fed the potato protein concentrate diet had the greatest amount of feces excreted. This is again likely due to the fiber present in this ingredient compared with the other protein sources. Phosphorus excretion was lowest in pigs fed the gelatin diet, while pigs fed the blood plasma and potato protein concentrate diets had the greatest phosphorus excretion. The high phosphorus excretion observed in the potato protein concentrate diet is likely the result of phytate present in this ingredient compared with the other protein sources. Basal endogenous loss of phosphorus was calculated by taking the fecal output of phosphorus and dividing it by the dry matter intake. Basal endogenous loss of phosphorus in pigs fed the gelatin diet is consistent with the 190 milligrams per kilogram dry matter intake that the NRC determined as the average value for the basal endogenous loss of phosphorus in growing pigs. The values for basal endogenous loss of phosphorus in pigs fed the spray-dried plasma and potato protein concentrate diets are close to values observed in previous experiments. However, both of these values are greater than those of pigs fed the gelatin diet, and therefore could result in an overestimation of the basal endogenous loss of phosphorus. However, the basal endogenous loss of phosphorus observed in pigs fed the casein diet is not different from that observed in pigs fed the gelatin diet, indicating that casein could be a possible alternative to gelatin when formulating diets to determine the basal endogenous loss of phosphorus. In conclusion, the basal endogenous loss of phosphorus was greater in pigs fed spray-dried plasma and potato protein concentrate, but no differences in the basal endogenous loss of phosphorus were observed between pigs fed the gelatin and casein diets. Therefore, casein may be used as an alternative to gelatin to determine basal endogenous loss of phosphorus, as it provides a greater amount of phosphorus but does not affect values for basal endogenous loss of phosphorus. I would like to thank you all for your interest in this presentation, and if you would like more information, you can visit our lab website at nutrition.ansi.illinois.edu. Thank you.